Good morning, everyone. Don't know who's here. Looks like 2 people so far. Hope everyone's doing all right. Happy Wednesday. Favorite day of the week? Not really. All right, if you're in the chat, let me know so I know who's here. All right, looks like we got 3 people. So, guys, if just to start class, I don't know if everyone hears me or anything, but to start off class, if you guys want to go over anything from yesterday, so any of progress check part A, any of those problems we can go over, start with, or if you want to just check your work, I'll go over the answers, and then we'll go through multiple choice question part B. So let me know if that's something you would like to do before you guys submit the assignment. Hopefully everything's okay on your end. I don't know if you guys are hearing me or if everything's all right. Drake, we can hear you over on this side. I think a lot of people are just waking up. Oh. Hey, Drake, just so you know, this first hour is going to be for BC. I don't know if you if you forgot about that, but AB will start at 10 o'clock. If you want to hang out and listen to some BC stuff, feel free. But yeah, come back at 10 and we'll get started on our end. But thank you for the feedback. I'm sure a lot of people are waking up. Yeah, you're right. Hey, Cole. Good to see ya. How's everything been? You doing all right? Good. Like the smiley face. Everything good, Cole? Hunter was saying the first day, I think it was Monday. He said you guys stayed up till like 4 in the morning. and you weren't gonna make the stream. All right, so I wonder who else is here. I wish it would tell me, but yes, everything great. See, Cole, I think this fits you. I feel like you probably like this kind of style of learning. A little bit more of be a little more independent. You don't have to worry about like being in class every single day. Right up your alley. Well, if you guys have any like I said, well, Cole, you're the only one I know who's here. But if you have any questions from yesterday's homework, please feel free to ask. Um, if not, you can get started on multiple choice question part B, which I posted. And then we can just go through that. Any questions you have as you go through, let me know. Hey Cole, I don't know if you're still there, but if you have any suggestions, I'm gonna play some music. Anything you want to listen to, you let me know. Feeling good with anything? All right. I'm just gonna play something relaxing, ease into the day a little bit. You know how it is. I don't know if you can really even hear it, but nice soothing piano in the morning. Can't complain. It's a little quiet, but I agree. Let me see if I can turn it up a little bit. Hunter was waiting for 26 minutes because he thought the stream was broken. I don't know if Hunter's here right now, but not broken. I'm just we're just vibing right now, Hunter. So if you guys don't have any questions, just like usual, if you guys got questions for me, I'm more than happy to talk. But I don't really want to I don't have like a comedy routine to go through anything. So me, Rachel, and Liberty were typing, wondering what was up. Yeah, I was. You guys are usually on time. I was wondering what was going on, and then Cole was the only one who answered, and Drake, and I was like, oh, guess there's only two here. Yeah, but I'm here, guys. I'm here. I'm here, ready to help if you need it. But so whoever's here, I see Hunter's here now. Cole's here. Rachel and Liberty. If you guys are here, just comment so I know. I thought maybe something was wrong. This time was kind of whack. Not gonna lie. Cole, let me know if you have any specific questions we can go over. You let me know. Hunter says, "Are we doing part A?" Hunter, we did part A yesterday. If you want to review something, I can go over the answers for you or a specific problem. Okay. Oof, number 2 on part B, but go over A. All good. I got some answers from the video of the stream from yesterday. Okay, Hunter. Cole, I don't know if you saw the stream. I haven't seen it yet, Cole. So just so you know, every stream I do, I'm going to post to YouTube. So if you are ever curious about any answers or anything maybe we went over during this hour stretch, you can watch that. I do believe we went over some, like Hunter said in the stream yesterday, so you can check that out. But number 2 on part B, I'll go over in a second, Cole. But I'll go over A. So I don't know. Again, I don't really know who's here, who's listening, but I'll go over the answers for part A, and you guys can let me know if you have any questions. So I'll give you a second. Flip to your part A just to double check. Okay, hopefully you have your notebook out in your work. So number 1 is D. Number 2 is A. Number 3 is A. Number 4 is C. Number 5 is D. Number 6 is B. Number 7 is D. Number 8 is A. Number 9 is B. Number 10 is D. Number 11 is C. And number 12 is D. So again, that was yesterday's multiple choice question, part A, for Unit 6. So give me some feedback in the chat if you guys are all good with that, so I can know. I think so. I'm good, I think. Okay. So Cole, you want to go over number 2 then on today's College Board, sounds like? Yeah, okay. So this is going to be the problem. Okay. So big thing to notice here is you can see that we have a composite function multiplied to another function. So one of our functions is g prime of x. The other function is arctangent squared of 2g of x plus 3. So we have an inner function 2g of x plus 3, outer function arctangent squared, and then we have another separate function g prime. So what we want to look at, just that setup, is automatically integration by u substitution. So that's just our definition of u substitution. And we let u equal to whatever's the inner function. So in this case, our inner function is 2g of x plus 3. All right, and then we do our normal u substitution. So du is going to be equal to 2g prime of x. Right, and then 1/2 du is going to be equal to g prime of x. And there should be a dx attached to both of those. Okay, and that's what I was ultimately looking for, right? I wanted to find something to cancel out g prime of x and d of x. Okay, now I got that. So let's write my new integral. I have, I'm just going to write arctangent of u squared du. Okay, now the question wants to know what is the value of, okay. So what we want to do here, just because based off of the fact that we're doing u substitution, we want to make all of the bounds in terms of u. Okay, so we want to take this equation here, and we want to figure out what's happening at x equals 0 and at x equals 4. So at 0 and at 4. Now if you go back to the College Board assignment, you can see we can get some of those values. So g of 0 is given to us as 1. So we would have 2 times 1 plus 3, which gives us u equals 5. Okay, and then at x equals 4, g of 4 is going to be negative 5 halves. So we have 2 times negative 5 halves plus 3 gives us negative 2. Let me just see my work real quick, make sure. Oh. Okay, it should be 1/2 arctangent of u squared. All right, so take a look at that, make sure that's okay for you. And now from here, what we want to do is we want to rewrite our integral. So now instead of having the integral from 0 to 4, we're going to go from 5 to negative 2. I'm going to take the 1/2 out front. I still have an arctangent of u squared du. Now my bounds are off, right? I have my lower bound is up at the top where it should be at lower. So negative 2 should be at the lower bound, 5 should be upper bound. So to account for that, we can rewrite by taking a negative out front and switching the bounds. Okay. And now, last part is we have a calculator, right? So all we got to do is in our calculator, plug in this value. Because our bounds are changed. So when we evaluate, we're going to evaluate those new bounds anyways. We're not going to replace u back. We're going to keep u with u. So we're basically all set with our integral. Now we don't want to go through and solve that. So instead we just put in our calculator, get an estimate. So I'll let you do that and then tell me what you get. Rachel, have you guys gone over part A yet? Yes, Rachel. Yeah, we went over it. But that's okay. I can still. What do you need? Yes, Liberty. Yeah, the answer is negative 3.647. Good. Rachel said, sorry, Liberty and I were on the other stream and we were very confused, so I just got here. Did I make another stream on accident or something? I think maybe I started one and it gave me an error, so I think that's maybe what happened. Rachel said 9 through 12. I want to check my answers, and Liberty says problem 10. Okay. So Rachel, I'll start with 9 through 12, and then Liberty, we can go over number 10. Okay, so on last night's homework for part A, number 9 is B. Number 10 is D. Number 11 is C. And number 12 is D. Cole, correct. You should have gotten B. Good job. Perfect. Those were all good. Thank you. No problem, Rachel. Liberty, you want to go over number 10, it looked like? Okay. So I'm going to go over number 10 from last night's homework in case anyone was curious. I'm just kind of reviewing what's going on there. But we have, hold on. Got to make sure this loads. Apologize. It's taking forever. Sorry about that, Liberty. I'm having a hard time getting the question open. All right, third time's a charm. All right, finally. Okay. So Liberty, just type in the chat real quick if you still need help with number 10 so I can go over it. I just got it up. I narrowed it down to B and D. I just don't know how to choose one over the other. Okay. So here's what we want to do. So first things first, we have given a function. We're taking an integral with bounds that have x and then a function that has t. So first, right off the bat, what we want to be thinking about is the fundamental theorem of calculus. So the fundamental theorem of calculus basically states that if you're given a problem that has this format, so the formal definition's in the book, and you can find that in the book. The idea is that if you're given something in this form, so you're given any sort of equation or any sort of function equal to an integral of another function, then we want to use FTC, or fundamental theorem of calculus. So what our first step we want to do is we want to find h prime. That's ultimately what we want to look for. So to use that, use the fundamental theorem of calculus, and you can rewrite you can rewrite the actual h prime of x is equal to cosecant of sine squared x raised to the fourth plus 1. Now, here's the big part, and this kind of comes down to where you narrowed it down. Make sure that the bound, the definition states that you plug in x for t, basically. And the reason being is because x, the derivative of x is just 1. So what we have to think about is using chain rule. So in order to evaluate a derivative, right, you have to multiply by the inner function, or the derivative of the inner function times the overall function. So this kind of acts like the overall function, but we need to multiply that by the derivative of sine squared x. Okay, and the derivative of sine squared x is 2 sine x cosine x. All right, and that narrows it down just based off of that part alone, the 2 sine x cosine of x, you can narrow it down to d as your answer. So really not much work for that, but using the fundamental theorem of calculus, just remember that whenever you plug in that bound, that upper bound, you have to use chain rule to find the derivative as well. Hopefully that helps. Let me know. Okay, that makes sense. Thank you. Yeah, no problem. I'm going to leave at like 10. I couldn't finish the MCQ. I'm on question 9, but I'm not sure if my answers thus far. Okay, cool. So here's your options for that. You can come in later today. So I have an office hour from 1 to 2. Hop in there for if you want for 5 minutes and I can go over the answers with you. I can just run down a list of what the answers are. So that's your option. Or we can talk about it tomorrow. So you can get work on it, keep working on it. Email me for any questions if you can't make any stream. And then tomorrow, just keep an idea of what you want to go over, and we can do it tomorrow during this time. Okay, so those are your options. You let me know what you want to do. Okay, I think I'll go over tomorrow if I have questions or talk to how to figure things out. Okay, cool. Sounds good. Can you go 1 through 9 right now? Yeah, sure, Liberty. Might as well do that. Okay, so number 1, so make sure obviously your notebook's out. Number 1, you should have gotten C. Number 2, you should have gotten B. Number 3, you should have gotten A. Number 4, you should have gotten C. Number 5, you should have gotten A. Number 6, you should have gotten D. Number 7, you should have gotten C. Number 8, you should have gotten D. And number 9, you should have gotten C. Thank you. You're welcome, Rachel. Hope you guys have a good rest of your day. You too. Thank you. All right, if you guys are coming in for AB, good morning, Zach. I'll be right back. So I'm going to give it 5 minutes, let people come on in, and then we'll get started. So make sure you guys get out your notes for AB. Morning, guys. I hope everyone's doing good this morning, this fine morning. Birds are singing. Wednesday's not usually my jam, but you know, I'm going to try to keep a good mood today. Thank you, everyone, for the greetings. All right, we got a pretty good showcase today. A pretty good turnout. This is good. Okay. So guys, make sure you have your calendars up and open. Work is out. All that good stuff. Hello there, Braden. Braden, I'm still disappointed. I never got that playlist. So 0 in the grade book for you. You kind of made a promise, didn't fall through. It's tough luck, Braden. Tough luck. So just trying to remind you. Just want to remind you. Smashing that like button. Oh, Ethan. Always appreciated. Whenever that like button gets smashed, I feel much better about my day. Make sure my camera's all good. Would appear so. Okay, kind of long title today. So today we're going to be talking about integration using long division and completing the square. So you guys can get that written down in your notebook. Don't need your textbooks. They don't talk about this in the textbooks, but this is an AP topic, so we got to be careful. Definitely want to go over it. Okay, in a couple more minutes and we'll get started. 18 people, 19 people. Pretty good turnout. Happy with that. Okay, so I'm gonna go ahead and get started, guys. Like I said, make sure you have your notebook out. Just looking at the calendar real quick, so you can see. You should see on the screen now. Um, Today, our plan is to first review the College Board from last night. So get that out. Any questions you have on that, we can talk about. That was the U substitution with definite integrals assignment. So we'll start by answering a couple questions on that. And then I'm going to get into notes on integration using long division and completing the square. So we're learning these integration techniques, basic integration, U substitution. And long division and completing the square is very similar in the sense of what we're doing. Our goal is we're going to try to rewrite integrals to make them easier to evaluate. So we want to rewrite them, and it'll allow us to evaluate them easier. All right, that's the game plan. That's the point of doing long division and completing the square. So we're going to talk about that, and then your homework will be Khan Academy integration using long division and completing the square. All right, so that's the game plan for today. But before we start with that, I would like to go over any homework assignments you have. So I'm going to wait. I see a couple people in the chat have a couple problems. So I got number 1, number 3. So everyone give me your input so I can kind of tally up the totals and see what people are thinking, what the consensus is. Okay, keep the feedback coming. I'm going to open up the assignment, and then I'll take a look at what you guys are looking for. So let me do College Board review. Okay, so number 6 definitely, and it looks like number 3, and then maybe 4 as well. Let me take a look at each one and see which one's good. So 3, 4, and 6 seem to be the primary problems. Okay, so 3, you get a calculator. 3, 4. Okay, let's do 3 and 6. I think 3 and 6 are going to be the more complicated ones. So let's do 3 and 6. So we'll start with 3. Okay, so if you guys have it open, it says the function f is continuous and the integral 0 to 8 of f of u du equals 6. What is the value of the integral of 1 to 3 of x f of x squared minus 1 with respect to x dx? So right off the bat, all right, so we see the function is continuous and we're given a value of an integral in terms of u. Okay, you don't see u unless you need to use u substitution. All right, you're never going to see a problem where it talks about u and it's not going to be u substitution with the integral. So that can be right off the bat like a hint, like, hey, we got to use some sort of u substitution. And you can see we're given a composite function multiplied by another function. So you're given x times f of x squared minus 1. Well, x squared minus 1 is your inner function, f of x is your outer function, and then the other function is x. So you get these three different pieces. This is the format of u substitution. So that's another hint to say, okay, we definitely have to use u substitution. And to do that, you always let u equal the inner function. So we let u equal x squared minus 1. And our goal for u substitution, as we know, is we always want to get rid of anything we can get rid of. So we have to write everything in terms of u. So I have f of u now, because u is equal to the inside of the function f. I need to find what dx or x dx is equal to. So I take the derivative, so du is equal to 2x dx, and then divide by 2 to find what just x dx is equal to, which ends up being 1/2 du. Alright, so that's your first step. You can also see, though, that the bounds change. So we have an original bounds in terms of x from 1 to 3. And then our f of u bounds become 0 to 8. So we have to rewrite the bounds in terms of u, which means we need to figure out at x equals 1 and at x equals 3, what are my new u bounds? Well, when I plug in 1 into the u equation, I get 1 minus 1, which is 0. When I plug in 3 into the u equation, I get 3 squared, which is 9, minus 1 is 8. Alright, so that gives us our u bounds, our new bounds. Alright, now we rewrite the problem. So essentially what we have is the integral from 0 to 8 of 1/2 times f of u du. So again, I take my pieces in that second integral, the integral from 1 to 3 that has all the x's, I'm replacing it with u. I'm using u substitution. And if I want to simplify this, you can take the 1/2 out front. So you just have the integral from 0 to 8 of f of u du times 1/2. Now we know what the integral from 0 to 8 is of f of u. That's equal to 6. So this is going to be equivalent to 1/2 times 6, which equals 3. So again, we know what the integral from 0 to 8 of f of u is. They tell us that in the problem, it's 6. So all we had to do is multiply that by 1/2, and that gives us the answer. So your answer for that would be B. I'm going to leave that up there. You guys can take a look. Tell me what you think. Okay, I don't know how long of a delay this is on, but just you'll have that work. Hopefully now you have the work down. You can take a second look at it. If you have any questions, let me know. And if you're watching this on YouTube, obviously pause the video, take a look, try to process all those questions there. Now, number 6. Let me move this down, see if I can even more. Alright, that should be good. So number 6 says, let f be a function such that the integral from 6 to 12 of f of 2x dx is equal to 10. Which of the following must be true? Alright, So we're given a function, f, and then we're given the integral of f of 2x and what it's equal to. So just like last problem, we want to figure out, well, we have to use some sort of substitution because this is a composite function, f of 2x. All right, it's being actually multiplied by another function of 1. But obviously that one's not as obvious to see, but this is a good situation for u substitution. And I did that work actually here. So you let u equal the inner function 2x. The derivative of u would be 2 dx. And then to find dx, you just take 1/2 du. All right, so that's your start to this problem. Got to start there. What I want to do next is I want to actually evaluate my new bounds. So I want to figure out everything in terms of u. Now you'll notice in the answers it's f of t. That's okay. We're going to use u as our substitution, and then it's going to end up just be equivalent to f of t, where f of t is just some other function. All right, so we have this. At x equals 6, u is going to be 12, and at x equals 12, u is going to be 24. Because 6 times 2 is 12, 12 times 2 is 24. All right, that's good for us because that's going to allow us to eliminate 3 of the answers. Okay, C through E isn't an option. So our new bounds dictate that we have to have A or B, which is good. All right, so we're making progress. Now, what I want to do now is rewrite what I have. So rewrite that original function they gave us. I'm saying what that's equal to, but in terms of u. So again, that original function, we're not changing it, we're just rewriting it. When we rewrite something, it's going to be the exact same value. It's just in a different form. So that different form is going to be with our new u bounds, and it's going to be our new function, f of u. And don't forget, I have that 1/2. So it's going to be 1/2 f of u du. All right, now from here, we can simplify this by taking out a 1/2. My bounds stay the same. And I have integral from 12 to 24 of f of u du. Okay, now from here, this is where I think a lot of people got to. So people were able to get to this point, then it's just a matter of deciding, okay, what does this mean? Well, we know that this entire thing, so let me write this actually in a different color. This whole statement I just wrote there is going to be equal to my original integral. Well, that original integral was equal to 10. So I have this big statement now. Okay, so I have the integral, or 1/2 times the integral of 12 to 24 of f of u du is going to be equal to my original integral they gave me, which was told to us that that was equal to 10. So we have these 3 equivalent statements. All right, but what we're focused on is we want to solve this first statement because that's how our answers are given to us. It's the integral from 12 to 24 of f of t. That's what we want to find. All right, so what we're setting up then is going to be a 1/2 is equal, or 1/2 times the integral of 12 to 24 of f of u du is equal to 10. That's going to give us a value. All right, and just like any math problem, right, we have to solve this like we would a normal equation. So we have to get rid of that 1/2, we multiply by 2 to both sides, which ultimately gives me the answer of 20. All right, so you set up that equation to get rid of the 1/2. So we want it in the form of just 12 to 24 of f of t. They used f of t. We used f of u. You have to multiply each side by 2 to get that by itself. And that's your final answer for number 6. So take a second, soak that in. Get Get your brains a little workout this morning. And we'll move on to our notes once I get a little bit of feedback in the chat to see how you guys are doing. Braden, I get it now. Good. Drake said, so using the u substitution, you can just turn the f of 2 dx, or f of 2x dx equal 10 to 1/2 f of u du equals a 10. Yes. Yeah, Drake. You want to obviously get the integrals. Even though we're not evaluating the integrals, you still want to get those bounds. That's going to be important as well. Yeah, exactly, Drake. Yeah, with the bounds changes and stuff. So that's essentially what we're doing. We're rewriting our original composite function in terms of just a one function f of u. Right? That's the premise of u substitution at the end of the day. Number 4, guys, I'm guessing it was probably like the end of number 4. If you guys want to go over number 4, you can come in later during our office hour and I'll do that. In terms of the actual u substitution aspect and the integral, the basic integral, it's pretty basic. It's straightforward. When you do your u substitution and actually go through that process, I'm assuming that wasn't what tripped you guys up. I'm guessing it was actually just finding what the right answer was, simplifying at the end. So if you guys want to come into my office hour at 1 o'clock, 1 to 2, then I can go over number 4. But in the meantime, since we got about 40 minutes left, I do want to spend time going over the notes. So this is going to be a new topic. We're going to be integrating using long division and u substitution. Long division and completing the square. Okay, and the first one we're going to do is long division. That's going to be the first problem we do. Oh yay! Complete the square. Yeah, Brandon. A lot of people have that reaction. It's like a visceral reaction to completing the square. Not I wouldn't say it's people's favorite topic, but that's okay. It's gonna be useful for us. I don't think this is gonna help ease your mind about completing the square. I hate to be the bearer of bad news, but that's okay. We'll work through it. Okay, so this is the problem you're given. Notice when we do complete the square, we will be using rational functions. We talked about this at the beginning of the year. Rational functions are when we have these polynomials over polynomials. All right, so we have just our basic x squareds, x's, x cubes. That's the type of situation, a rational function. So it's always going to be a fraction, right? It's always going to be polynomials on the numerator and denominator. That's how we can tell, okay, we want to use long division. And again, the point of long division isn't it's going to solve the integral for us. We're not using long division as this method to solve an integral. Okay, we still have our basic antiderivatives. The point of long division is because looking at this problem right now, there's no u substitution I can do. So I can't let u equal 2x minus 1. I can't let u equal x minus 2. I could try, but you're not going to get anywhere with it. So to account for that, because u substitution doesn't work, we don't have a basic antiderivative yet, we can use long division. Now to set up long division, remember, we have my divisor and my dividend. So divisor is x minus 2. My dividend is 2x minus 1. So the x minus 2 is dividing the 2x minus 1. And the 2x minus 1 is getting divided. All right, and this is a fairly basic polynomial log division problem. But as a reminder of how we do that, so your first goal is to take the first part of your divisor. So that's, in this case, it's x. It could be x squared. It could be 3x squared, 3x cubed. You don't really know. But you take that and you say, okay, what do I have to multiply that by to get to 2x? All right, that's the goal. What do I have to multiply that to get to 2x? Well, 2 times 2x gives me 2x. All right, easy enough. All right, just like normal log division, we're subtracting values. All right, and that 2 times x will go down here at the bottom. 2 times negative 4 gives me, or 2 times negative 2 gives me negative 4. So again, whatever number you put at the top, you have to multiply or distribute kind of to both values in the divisor. So 2x minus 2x is 0. That's the goal, right? We shouldn't be doing this problem where that doesn't be 0. Negative 1 minus a negative 4 is a positive 3 because you're adding. Right? Negative 1 plus 4 is 3. So that becomes my remainder because there's no x can't multiply by anything to give me 3. All right, so I get 2 plus 3 over x minus 2. That's my new remainder. So if you guys remember, when you write a remainder, you take your value divided by your quotient. Or sorry, your divisor, not your quotient. Okay, so now what I did was I just rewrote the inside of that integral. Right, I didn't solve the integral. I didn't change any values. I just rewrote it. What I wrote inside that integral is equal to the original integral. But you can see this one's much easier to solve because I can split this up into two separate integrals, right? So you take the integral of the first term, integral of 2, plus, I took the 3 out front, so I did a little bit more steps in one. So I took the 3 out front, and I have the integral of 1 over x minus 2. You don't need to split it up like that. That's just how I'm choosing to do that. All right, and these are basic antiderivatives here. So the integral of 2 is 2x. The integral of 1 over x minus 2 is the natural log of x minus 2. And then we know, right, it's plus c. So that's my final answer, 2x plus 3 natural log of x minus 2 plus c. Ethan, 2 plus 3 over u. I don't know where you're getting the u from. No u substitution needed here. So again, the whole point of the long division was just to rewrite it. I guess you could use u substitution if that's what you're saying, maybe. You could use u substitution. It's not necessary because we can get to the natural log just by looking at it in this situation, but u substitution would also give you the answer if that's maybe what you were referencing there. So let me get some more feedback in the chat, see if you guys are good with that, if you need more, if you have any questions or what the deal is. Makes sense. Jaden said vibing. Jaden, is that Mike Wazowski as your profile picture? Looks like it is. Good. Jay chillin'. Good grammar there, Peyton. All right. So it looks like I'm getting pretty good feedback on that. Bien. Ah, Espanol. Sí, Braden. Muy bien, hopefully. Okay. Jane said yes. All right. All right, let me go down a little bit. This will be our second problem. All right, so what I'm going to do for this one is I'm going to give you the problem and I'm going to let you guys work through it. So we're going to have an integral of 6x squared plus 5x minus 3 over 2x plus 1. That's going to be the problem I'm giving you. So your guys' job then is to use what we just did in the last problem, see if you can go through and solve that. So use long division, rewrite, and then try to evaluate the integral that's left over. So I'll give you guys about 7 minutes-ish to do that. So when you guys get done, kind of like Ethan said, just give me, you don't have to put your answer, as long as you just let me know, like, hey, I'm good, ready to go over it. All right. Looks like maybe people are finishing up. Maybe about a minute or two more. I'm gonna get us started, so those of you who are done can check your work. Ethan, not getting some feedback on that. It's okay. We'll go over it. It'll be all right. Okay, so this is the problem we're set up with. Same idea. We want to see, okay, 2x times what gives me 6x squared? So it should be 3x. 3x times 1 is positive 3x. So I get 0. 5x minus 3x is 2x. Okay, and you bring down the 3. 2x times 1 gives me 2x. 1 times 1 gives me 1. Negative 3 minus 1 gives me negative 4. So that becomes my remainder. Alexa said, I don't know what the laughing face is for. Alexis, I thought you were just laughing at Ethan. Okay, so from here, this is our new integral. Let me see if you guys can see this. Gotta make sure. Okay. So our new integral now becomes 3x plus 1 minus 4 over 2x plus 1. Okay, so from here, we're going to split this up. I'm just going to split it up because I think it's going to be a little bit easier to see. So the integral of 1 minus 4 times the integral of 1 over 2x plus 1. Okay, so I'm splitting up into the integral of 3x plus the integral of 1 minus 4 times the integral of 1 over 2x plus 1. Okay, so if you guys aren't comfortable with this, I kind of mentioned this last problem with that Ethan said. You can use U substitution from here. So you can use U substitution and I can actually get the same answer. Now, you don't necessarily need to. So from here, first of all, the first part, we got 3x. The integral of 3x is 3 halves x squared. The integral of 1 is just x. All right, so those are the easy parts. Now, this integral right here of 1 over 2x plus 1, we know it's going to be 4 natural log of 2x plus 1. Okay, we can get there. That part is for sure. Now, the question, though, is that the denominator, you can see this isn't the normal form because we have that 2 out front. All right, because before we were taking derivatives, like, for example, number 1, we took the derivative, and the derivative of the denominator was just 1. So we didn't have to worry about it. Well, the derivative of this denominator is 2. So remember, reversing that chain rule, you want to divide by 2. So it's going to be minus 4 natural log of 2x plus 1 all divided by 2. Always dividing by the derivative of the inner function. Again, U substitution. This is almost skipping U substitution. If we used U substitution, you would get this answer no problem. And I have absolutely no problem with you guys doing that. Just for the sake of time, I didn't use it. All right, and then clearly these will cancel. Not really cancel, but they will simplify, and you'll get 2 natural log of 2x plus 1. So your final answer is 3 halves x squared plus x minus 2 times the natural log of 2x plus 1. And then, of course, plus c. All right, and that would be your final answer. So just let me know, guys, in the chat then what are your consensuses on that. Any feedback I can get to help you out, let me know. It's all right, good. Braden said okay symbol, perfect. All right, cool. So if you guys look again, as a reminder, why are we doing long division? Or like what tells us to long division? Well, the original function inside of the integral. So you can see this original rational function. U substitution right off the bat isn't going to help us much. Primarily because if we were to use U substitution, we would have to make the U substitution the numerator. And if we're making the U substitution the numerator, it's going to put du in the denominator, which we don't want. All right, so right off the bat, we're thinking this isn't really a great setup. It's also a rational function, not a composite function. So no good for that. Your second idea is like, okay, well, can I factor? You could try. No guarantees. So you might want to factor, see what happens, see if you can cancel out 2x plus 1. That would make your life really easy. In this problem, it doesn't work that well. So you would have went through that process for no reason. But that's not a horrible step to take, is trying to factor and cancel terms. But what really gives it away is the fact that the numerator has a higher power than the denominator, and it's a rational function. That's what we're really looking for, the numerator having a higher power and it being a rational function. That's kind of your giveaway. Okay, now when we're using completing the square, it's going to be a little bit different. So I'm going to flip this paper here. And we're going to do completing the square with an exclamation point because we're very excited to do this. And I know we are because I know my students so well. All right, so the plan for this, again, similarly to long division, is there's really no, there's no rule, there's no definition, nothing really to talk about. It's just another method to simplify integrals so we can take a general or a basic antiderivative. So your first problem is going to be to find the integral of 1 over 4x squared plus 48x plus 148 dx. And that's your first question. Now I'll go through it. If you'd really like to, you could pause the stream and try on your own, and then just fast forward and see my explanation if you'd like, but I'm going to walk through the first time. Now, again, this is the difference between a completing the square problem and a long division. You'll see that the numerator power is less than the denominator. So this has an x squared, this has an x to the 0. So that's your first step, or your first, thing to notice. Second thing to notice is U substitution ain't going to work. All right, so 4x squared, if I do that as my U substitution, I'm not going to be able to cancel out 1 because my derivative is going to give me something with an x in it. So that's no good, not what we're looking for. So you can eliminate U substitution right off the bat. You can eliminate long division off the bat. Now, completing the square is the only other method we have other than rewriting. If I look to rewrite, not much I can really do in terms of I can't cancel anything out because there's no polynomial up here. So, this kind of leads us to just this one idea, which is completing the square. All right, so first thing I want to do to make my life a little bit easier is I'm going to factor out a 4 in the denominator. So I get the integral of 1 over 4 times the quantity, x squared plus 12x plus 37. All right, just a factoring problem. Just factor out a 4. Now this is the step where we get U substitution. Now bear with me here. Okay, this is the hard part. And even though it's a concept that we learned when we were in algebra, 2 or 1 even, maybe, it's still an issue, or still a problem that gives a lot of people issues. So before I actually get to that, though, I do want to just take out the 1/4. And I just want to do that just because personally I just like making things look easier, look nicer. So taking out that 1/4 just brings me down in the denominator. So all I got to deal with is 1 over some polynomial. Okay, now we complete the square. So the idea of completing the square is you're going to take 1/2 of b and square it. So meaning that here's my polynomial. I have x squared plus 12x plus 37. Okay, the 37 we're just going to ignore. Now it's really super important you guys remember this. We're not changing anything. We don't want to change the problem. So if you guys remember when we did completing the square like in algebra, right? The idea was that we had the same equation. We weren't changing the equation. If you change the equation, you have a different problem. So all we did with completing the square was we rewrote. If you guys remember, we would add something to one side of the equation. Whatever we added, we would also have to add to the other side of the equation. And it's the same idea here. We want to use completing the square to rewrite x squared plus 12x plus 37, but we don't want to change that value. So it should still be x squared plus 12x plus 37 in the denominator. All right, and to do that, we use completing the square. So we take 1/2 of b. When I say 1/2 b, it means the 1/2 of the coefficient of the second term, or the linear term. The coefficient is 12. 1/2 of 12 is 6. 6 squared is 36. So we add a 36 on the end there. Now this is a completely different equation. Or I guess I shouldn't say equation, this is a completely different quadratic. Right? X squared plus 12x plus 36 isn't equal to x squared plus 12x plus 37. So to account for that, we would just have to add 1. Right? Because 36 plus 1 is 37. So, Mr. Harris, why are we doing this? This seems really stupid. All you did was rewrite 37 as 36 plus 1. Yes, you're correct. But what's useful about this is because we have what's called a perfect square trinomial. So right there, that trinomial, that quadratic, is a perfect square. All right, and that perfect square factors into x plus 6 squared. All right, and to find that value, you just take the square root of the first and last terms of the perfect square. So you take the square root of x squared to get x, square root of 36 to get 6. If you want to check your work, you can FOIL x plus 6 out, and you can actually get the value. So you can always check your work. And don't forget, I still have that plus 1. So you got to make sure that you add that 1 at the end there. And I'm hoping maybe you guys are seeing we're getting some progress. Okay, we're getting somewhere. Because now we're in a position where this integral is very close to being able to just take it. It's very close to being a basic antiderivative. All right, now from here, what I want to do is use u substitution. And this will always be the case with completing the square. Okay, you're always going to have to use u substitution at some point. We're going to let u equal my inner function x plus 6. So you can see I have an inner function x plus 6 squared. I have a composite function x plus 6 squared. The inner function is x plus 6. Okay, which means du is equal to 1 dx. Now this is good. I forgot to write them up here, and I have that tendency to do that. But right, we're looking to get rid of 1 dx. And we have that now. It's du. So with that information, we can rewrite this as 1/4 times the integral of 1 over u squared plus 1 du. All right, so now we have 1/4 times the integral 1 over u squared plus 1 du. Okay, now the really tricky part is we have to remember this, and I know it's hard. It's been a while, but this is equal to 1/4 times arc tangent of u. So if you guys remember, the derivative of arctangent is 1 over x squared plus 1. Or 1 over 1 plus x squared, however you want to look at it. Same idea here, except instead of x, we have a u. 1 over u squared plus 1. So that's arctangent. The integral of that is arctangent. All right, so your final answer becomes, replacing back for u, 1/4 arctangent of x plus 6 plus c is your final answer for that. So take a second, guys. Process that. Let me know if you have any questions. Not this again. Me plus trig functions equals no bueno. I know, guys. I know. It's gonna take some time. It's at the end of the day is we just have to see these enough where we can remember kind of the setups. Okay, so what's really important is I'm getting the same feedback, which I appreciate. Is for completing the square, guys, it's always going to end up being a trig function's answer. So if you noticed the when we did long division, we got natural log answers, right? So we'd get like a general antiderivative, but it would always be natural log. And the reason for that was because we always had a remainder over a linear function. So we had like 1 over x plus 2. Well, that's always going to be the antiderivative. That's always a natural log. So you guys will see these patterns, right? Whenever you do long division, you're going to get some sort of normal antiderivatives and most likely a natural log. Whenever you do completing the square, you're always going to get a inverse trig answer. Okay, which means you're going to get an answer of either tangent inverse or inverse tangent. You're going to get an answer of inverse sine and maybe an answer of inverse cosine. Are these questions really prevalent on the AP test? No, they're not super prevalent, but this is a necessary strategy to use to get an integral. So like I've said before, it kind of comes back to, oh, thank you, Mr. Colan, for the thumbs up. Like I said before, guys, it kind of comes back to the idea of reviewing what we've learned in the past with these identities. Identities are super important. Feel free to write them down. It's a good way to practice, get note cards, whatever you got to do. Okay, so I want you guys to copy down what I have in the blue there. Now this is just a process. So the one we just had, that was a taking the antiderivative of 1 over u squared plus 1 is very easy because it's an identity. It's not always going to be set up that easily. So what you guys can see is in this note, if you're given an integral of 1 over x plus h squared plus k squared, so if anything in this form, which when we complete the square we'll always be getting stuff in this form, you can take a shortcut and say that's going to be equal to 1 over k times arctangent of x plus h over k. All right, this can be our little shortcut. So I want you guys to take a second, copy that down. So it's always going to be tangent. Not necessarily, Alexis. You'll see problems potentially tomorrow we might see a problem where it might be inverse sine or inverse cosine. Those ones are a little bit more challenging. But I don't know if I'm going to necessarily address them and take time on them. But yes, generally it's going to be an inverse tangent. Now, if you guys remember, the key difference is tangent, there's no square root in the denominator. So it's just 1 over x squared plus 1. But with inverse sine and inverse cosine, those derivatives have square roots in the denominator. So if you're ever doing a problem and using completing the square with a square root, you're going to end up with a inverse sine answer or an inverse cosine answer. Good question, though. Okay, and due to time, I'm not going to be able to do any more problems today because we only got 5 more minutes. So just make sure you guys know that for homework, so let me switch back to facing screen. Okay, so for homework today, we have Khan Academy, integration using long division and completing the square. So I believe I already assigned that assignment to you. So you guys can get started on that in the next couple minutes if you want to work on that. That's fine. Just this is Khan Academy as always is a little bit more basic, so I don't foresee too many issues with it. It'll be good practice. Now tomorrow, what we're going to be doing is we're going to be doing College Board. So we're going to do a College Board assignment with this stuff, and that one's going to be a little bit more challenging, but not too bad. So just so you guys know, that's the plan. Other than that, we are good. Peyton, I just saw your question. Is that a 1 over k, 1 divided by k? How does that apply to the previous problem? Wouldn't k equal 1, but it's 1/4? Let me see, Peyton. Let me see what you're saying here. So this note here doesn't apply directly to the previous problem. If you were to, let me scroll down here. Okay, so we'll take a look at like right here. I'll just circle it just so you can see it, Peyton. So guys, Peyton's question is basically asking how does that note apply to the problem we just did? Okay, so for this problem, right, our x is x, that stays the same. Our h becomes 6, so now we have an h of 6. Our k is 1, because 1 squared is 1. So that becomes my k. All right, so if I look down then, if I look down at our note, my k is 1, so it's going to be 1 over 1. Inverse tangent of x plus, in this case, 6, divided by 1. All right, if you look at my answer, that's what I got. X plus 6 divided by 1, and then 1/4 times 1 is 1/4 plus c. So that's why we can use that Peyton. We can use the note. We can use that kind of shortcut. But in this problem, since our k is 1, it doesn't really impact the answer too much. Yeah, so that 1/4 out front, right? And Emma, k is any constant. Specifically, Emma, it's a perfect square. So it's not really just it is a constant, but it's the square root of whatever your value is on the denominator at the end. Yeah, I got you, Payne. All right, so you guys are good to go. I appreciate you all participating. If you're watching on YouTube, hopefully this is helpful. Make sure you guys email me if you have any questions. I have an office hour from 1 to 2, and I will be answering emails from 2 to 3. So any questions you guys have on the Khan Academy or notes, whatever you may want to go over, let me know. So that concludes AB. Hope you guys are all doing good. Hope everything's okay. Other classes are going well. I appreciate, again, the effort you're putting into my class, so keep that up. And enjoy the rest of the day. Algebra 2, here we come. You're right, Michael. Woohoo, Algebra 2 time. Yeah, Molly, love the energy. I've never seen you guys so excited to be doing math. But I know Michael, you can never really tell with him. He might be just be joking around. Giving me a hard time, acting like he's all engaged. Good morning, Sarah. Yes, Algebra 2, here we come. Yeah, guys. Love the energy. Love it. And by the way, the homework, I need help bad. All right, Michael. Thank you for the feedback. Okay, it looks like I'm a little glitchy right now. Hopefully you guys, my feed's coming in okay and you can hear me and stuff, even though my movements are all glitched out a little bit. I think we need a lunch hangman stream. Oh, that'd be funny. All right, Molly, I'll think of one right now. I'll do it on the whiteboard behind me. Hold on. Let me see if I can see this. We're gonna do, Molly, put a topic in the chat. We can do. I don't know if you can see that. Hold on. Once I get a topic, I'll write out the letters. You might not be able to see the guy, but you'll be able to see the word. Food. Okay, I'm doing food. Food's a topic. Good morning, Gidio. Let me see. I gotta make sure to see if you guys can see the. Yeah, you can see that fine, I think. All right, give me some letters. A. Okay. Molly, great guess with A. S. Okay, A and S, good ones both. Oranges, no, Michael, wrong. Good morning, Isaac. C. Luke C says C. Sorry, Luke, no C. Savannah says N. Good guess. N is correct. Banana, no, not banana. I'm gonna give you a limb for that. Okay, your guy's getting a body. Lasagna, Heaven, good. Heaven was the first one I saw. Lasagna. I don't know why that was the first thing that came to my mind, but it doesn't come into this when it's Savannah. Yes. I don't know why lasagna was on my mind. All right, riveting game right there. Well done, everyone. It's really hard to. You know what? Maybe I gotta think of a better one next time. Lasagna was too easy. It was the A. You gotta pick letters or you gotta pick words that don't have very many vowels. Because the ones that don't have very many vowels, people have a hard time guessing. I hate Savannah. You can't hate lasagna. Lasagna is gross. Can I be honest with you guys? This is kind of a hot take. I don't know if you'll agree with this. I think lasagna is better left over. I'm willing to go on a limb and say that. I think lasagna is better the next day. Get some like buttered bread and like when you're done with lasagna and all that extra sauce and like leftover stuff, just like dip the buttered bread in it. Oh, big fan, big fan. You should have lasagna for breakfast. I could see myself doing that, Molly, for sure. One time I made a breakfast of leftover pizza. So what I did was I took the pizza and I combined it with eggs and cheese and like cooked it. So like I cooked cracked a couple eggs, cooked it. And like I made it like not really scrambled, but I guess like I mixed it all together. So I guess it was kind of scrambled, but I put cheese and then I cut up pizza, like the leftover pizza. It was like supreme pizza, into like really small little bites. And then I cooked it all together. Oh, put cheese on it and hot sauce on the top. It was fantastic. I recommend it. I just took a video of it, but yeah. I don't know. I mean, hey, this is our team building exercise while everyone gets into the chat, Michael. So I don't care who's watching. This is good. This is stuff we need right now. Important conversation. I'm teaching you cooking and math. You don't get that everywhere. I think cold pizza is pretty good, like chicken barbecue. Oh, Drake, speaking my language. Chicken barbecue pizza is the best. Dip it in some ranch. Oh, now we're talking. I'm sorry, but pizza and egg, Justin, I get it. Listen, I get it. I'm not defending myself, but it's one of those things where it's like you don't realize how good it is until you try it. Okay, you don't think it would be a good combination, but if you haven't tried it, you can't really speak to it. You know what I'm saying? So you experiment. Let me know. You can post it to Google Classroom, a picture of your work, and then we can all judge it. Pineapple on pizza, I'm a big fan of, Molly. I support it. 100% support it. Drake, new favorite teacher. Drake, new favorite teacher? I'm offended. I thought it was always. All right. Looks like people should be settling in here. Make sure you guys get your books open and out. I'm going to do it the same. And we are going to pick up where we left off yesterday. But before we do that, we're going to do some homework questions. So I know, Michael, I got feedback from you, but anyone else who needs some help with the homework, please put in your questions into the chat. All right, and we're going to do some homework review. Let me switch my camera over here. Okay. You could call it Chef Harris. Yeah, that's what I'm saying, Isaac. I might be a chef, honestly. It might be my calling. You're always top 5. Appreciate it, Jake. Damon, what page? That's actually a good question. Your page is 480 is the homework. Yeah, my 480 is the homework question. All right, so Haley said number 15. Michael said 13 and 17. Sierra says, why did I end up with 2 answers for a few of the questions? Okay, that's a good question, Sierra, and you should end up with 2 of the questions. Or 2 of answers for a few questions. Can we go over how to graph 15 through 19? 19. Okay, so I'm getting some pretty good feedback. Let's look at these types of problems. Okay, so let's look at 13 real quick. All right, so number 13, guys, we have log base x of 27 equals 3/2. Okay, that's what's given to us. Now, we're going to get to a point where we can do this problem, and it's not going to be, it's going to be a little bit different. So we're going to use logarithms, and it's going to help us solve this problem. But for now, what you wanted to do is just rewrite this in exponential form. So that's all we've learned so far. Meaning that the base of the logarithm over here turns into the base of my exponential. So I've said this before, I've said it a million times now, right? We always want to take that b in the base, and make it an exponential base. And whatever's on that side, you raise that to the exponent. So we have 27 equals x to the 3/2. Now there's no perfect way to do this. The idea is what we wanted you to do is you could graph it. So you could graph the graph of x to the 3/2 and find out where that crosses or where that equals 27. So that's option number 1. Option number 2 is guess and check. So you can just pick values and then figure out, okay, just kind of eliminate some solutions. Like if you try x equals 30, you're going to find out, nope, definitely not it. And then you're going to work your way down. You know, maybe x is 10. You're going to find, no, it's too big. Then you're going to keep working down, and so on. And eventually what you're going to get is that equals 9. So I know I don't have like a ton of work for that, but again, it's going to be your calculator you're going to have to rely on a little bit once you get to that exponential portion. Okay, so I'm going to wait a second. Let's see if any feedback on that one. And all of the beginning of the homework was those types of problems. So you do the same thing for every single one of those. Sorry, I was in the wrong stream. No problem, Tanis. Thank you for making it. I think I might have accidentally started a stream or something, because first period had issues too, but I don't know. Okay, so I'm not seeing anyone, any issues going on. Did we have to graph them? No, you didn't have to graph them. You could have graphed them to solve. Like for 13, like I said, you could have graphed 13, and then that would have given you the answer. But no, the question just wanted you to solve each equation. So I guess actually, Digidio, I'm sorry, I didn't see your question either, but yeah, we don't need to graph them. I can still go over how to graph them if we want, but we didn't need to graph them. Okay, so maybe I'll go over the algebra part, and then I'll show you in Desmos how we can throw that in the calculator. Okay, so I'm going to start on 19. All right, so very first thing we want to identify. All right, so we have log base 7, log base 7. If we have the same base, just like if we have the same base of an exponential, we can just set what's on the inside equal. So in this case, the logarithm, we set what's inside of the parentheses equal to one another. The only way that this statement is true, the only way that this can equal that, is if the inner function equals each other. Because they both have logs, they both have the same base. Just like an exponential, if you both have a base of 2, then their exponents have to be equal. Same idea, same concept. Okay, so what we're doing now that we have this equation, is now we just want to solve. We want to find x. That was the question. The question says solve each equation, meaning we're solving for x. To do that, I want to set up a quadratic equation equal to 0. And we've done this. This is review. So we want to set up a quadratic equation to solve for x. Because I have an x squared up here, I have a linear term x, and then I have a constant. So I add x to both sides, and then I subtract 2 from both sides, and I get x squared plus x minus 6 equals 0. Okay, now from here, you want to do your x box. A times c, or 1 times negative 6, is negative 6. Your b term is out in front of the x, which is 1. And we want to find two values that multiply to negative 6 and add to 1. Okay? And to do that, you want to just kind of guess and check. Pick values that multiply to negative 6 and then work from there. And you end up getting that 3 times negative 2 gives you negative 6, and 3 plus negative 2 gives you positive 1. So those would be my values. Because a is 1, I can take the shortcut. So my factored form is going to be x plus whatever one of your sides of the x box is, times x plus the other part of your x box, which is a minus 2, so x minus 2. That's going to be equal to 0. Which means x equals negative 3 and x equals 2. And this leads me into Sierra's question. So Sierra's question in the chat was, she said, why did I end up with 2 answers for a few of the questions? Like this, okay? And the reason you end up with 2 answers is because with quadratic equations, right, we have 2 answers. Now, this isn't a quadratic equation, though. We have to look back at what the original question was asking. Okay, the original question was asking us to solve for this. Solve for x to make this true. Now, we had to use the tool of factoring quadratic equations, but now we have to actually process, okay, what does this mean? What are our answers giving us? How do we work with them? And to do that is we have to actually evaluate the logarithms at both of those points. So we want to evaluate the logarithm when x is negative 3 and when x is 2. And what you get for -3 is you get log base 7 of -3 squared, which is 9. 9 minus 4 is 5. Equals log base 7 of -3 times -1, which is 3, plus 2, which is 5. All right, so you have log base 7 of 5 equals log base 7 of 5. Now this is the important thing, or distinction, I guess, to make, is the domain of a logarithm. If you guys remember, if you graphed a logarithm, we have an asymptote. It's called a vertical asymptote at y equals 0, meaning that there is no x values left of 0. There can't be any x values. So there's no x values at 0 and there's none left because we have an asymptote. Like, think of it as a wall. It's cutting it off. But in this case, log base 7 of 5, that works. That's a value. So that's an actual real solution. When x is at -3, we actually do get a value. Okay, so if you were to graph this, you would find that this gives you a number, gives you a value. If we try at x equals 2, we get log base 7 of 0 equals log base 7 of 0. Okay, now log base 7 of 0 isn't a value that's in our domain. Log base 7 of 0 is actually outside of our domain. There's an asymptote at 0. So if you were to put that in, you're not going to get a value. So maybe it'd be beneficial. I'll switch the camera here. And I will go to Desmos. And we can kind of let's take a look at some of these graphs. So again, it says that log base 7 of 0 equals log base 7 of 0. Well, let's check out what happens when I evaluate that. So you'll see, kind of interesting, right? It's undefined. That's what we call it, an extraneous solution. It is a solution that makes it true, makes the statement true, but it's not a solution that's present on the graph. So kind of think of extraneous as not realistic. But if I have log base 7 of 5, oops, you guys can see that gives me a value. So it's not extraneous, that's an actual value. That's a true statement, so that's in our domain. And that's how you always want to check your work here. You can just see which one of them gives us an actual answer. And sometimes, like Sierra said, you can get both. They can both give you an answer. Damon, I just saw your question. Wait, did we have to write what you have after x equals 3, x equals 2? Because I just stopped there. Yeah, Damon, you did a really good job at getting to that point. You do have to do the next part, unless you can analyze just right from there. Like, so let me flip back to my work. Damon, if you got to here and you plug those in a calculator and just found, oh, this is my answer, which, by the way, if you guys didn't catch on, that's my answer. If you found that worked and x equals 2 was extraneous by using a calculator, you're good. Okay, that's enough work. But you have to tell me you used a calculator. You're welcome, Sierra, for the explanation. Okay, so real quick, let me just show you guys something interesting here too. So I want to actually graph these. So I'm going to do log base 7 of x squared minus 4, and then log base 7 of negative x plus 2. Okay, so I know you can't see it, but I'm doing that on purpose. So I put that in the graph. So just imagine in Desmos, I put those in the graph. What would you guys expect to see? What should you be looking for? If we want to know when those are equal, what should you be looking for? So just take a second once my delay catches up and you guys are hearing what I'm saying now. Take a second and think about, if I were to graph those original equation that we were given for 19, what would I expect to see? That's my question. Do 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 do. 0 for them to touch on the graph. Perfect. That's what I'm looking for. Okay, we want to see those graphs. Where do they meet? Where do they cross one another? All right, so now let's take a look at my screen. Okay, you guys can see this is what I graphed, right? I graphed each side of the equation. Notice this is the only spot they cross. Okay, they cross at -3.80 or 0.827. So it would make sense that my answer would be -3. If you guys notice here, notice even Desmos kind of gives it away a little bit, which is pretty cool about Desmos, right? You can see a dot. It will show you the intersect. But for at x equals 2, it doesn't actually give me an intersect. So I can keep scrolling down, and it looks like they overlap. I get that. And they really do. They kind of become one graph there. But it doesn't give me a point in which they graph, or which they meet, because that point is undefined. Okay, again, it's really important to make that distinction. Your intersection, your answer is where the graphs cross, and there's a point that you can click on in Desmos. So it's a defined point. If you ever see a graph that looks like it crosses but doesn't tell you where the point is, then that means it's undefined. So even though it may appear like it's crossing, it's not. Okay, so hopefully that clears some stuff up. Just being able to look at a graph and I kind of understand what's happening. Okay. Very good job, guys, for that. Let me switch to my notebook and let's take a look at today's lesson. So we're going to continue our notes from yesterday. All right, so just get those out. Same exact chapter, same title. We're just going to do a couple different things. Specifically, we're going to be working with inequalities. So in your guys' book, page 479 is where we will be. So maybe give me a comment in the chat, maybe saying like good or thumbs up or maybe like a radical sign, something like that. So I know you guys are good to go. You're on page 479, ready to take notes. Good, good thumbs up, radical sign. I was having internet issues. Sorry, no problem, Darren. I appreciate you showing up. You can watch the beginning of the lecture, which was riveting stuff, by the way, because we played Hangman. You can watch that on my YouTube channel. Oh, and while you're there, go ahead and smash that like and subscribe and comment. You know, the usual. What time is the homework due, Michael? This homework, tonight's homework, I'm not going to have you submit it to Google Classroom, so I'm not going to be able to check it, which kind of means it's just due when you get back to school, whenever that is. I recommend just get it done now, and so you don't have to postpone it. If we have school again, right. I put the page number in case anyone's concerned. Okay, I think we should be good. So at the bottom of page 479, I'm just going to kind of read what they got here. So it says solving logarithmic inequalities. A logarithmic inequality is an inequality that involves logarithms. Don't you just love math definitions? That's just a fantastically worded phrase there. Let me actually switch to the, might as well switch to the book so you guys can see my book as well. So it says it's an inequality that involves logarithms. Perfect. Great definition. The following property can be used to solve logarithmic inequalities. There's really no, I guess there's really no need for us to copy down these properties. It is interesting to note though. So if you guys look, the first thing they are doing, so given this type of problem, the first thing they're going to be doing is rewriting into exponential. So we're used to seeing stuff in exponential. Remember, it's not changing the problem, it's just rewriting it in a different way. So their example is if b is greater than 1 and x is greater than 0, and log base b of x is greater than y. So basically, if everything's greater than, then x is greater than b to the y. So they took the base, they made that the exponential base, raised it to the y, set it less than to x. If b is greater than 1 and x is greater than 0, and log base b of x is less than y, then 0 is less than x, which is less than b to the y. Okay, so I wish I could highlight, but you can't really see. These are properties for inequalities of logarithmic functions. Now, I want to point out this part here. So the fact that 0 is less than x is less than b to the y. So before, all we had was x is greater than b to the y. But now we're saying 0 is less than x, which is less than b to the y. So we added that 0. Again, I want you to think about why. So our parent function is in this form, log base b of x. We know our parent function has an asymptote at x equals 0. So it would make sense that no matter what x is, it can't be less than 0. So it has to be greater than 0 because there's an asymptote there. So we don't have any x values left of there. No x values at 0. So that's why they state this, why they make that distinction, just so everyone's aware. Sierra, I just saw your comment. Will you post what homework is in the Google Classroom? No. My calendar will tell you the homework, Sierra. So it already is in Google Classroom. It's just under my calendar instead of like under an assignments page. So you guys can always check my calendars and they'll give you the updated assignments. Okay, so back to my my notebook here. We're going to just take a look at example 3, which is log base 3 of x is greater than 4. So let's just take a look at that. Like I said, okay, so we're given an original inequality. Again, it's an inequality. It's a greater than symbol. We want to start by writing that in exponential form. So when we write that in exponential form, right, we take the base 3, and we make it the base on the opposite side of the inequality, raise it to that exponent, so 3 to the 4th, and you're left with just what's on the other side, the left side. So you're left with just x. Okay, and pretty easily, right, simplifying, we just put in our calculator what 3 to the 4th is, and you get x is greater than 81. There's no more work. That's it. Okay, not overcomplicated, nothing crazy. That's all we're doing. Okay, so these are kind of like, just like the equations, these are like the basic examples. So we did basic examples of equations and then harder examples. Inequalities, we're going to do basic examples of inequalities, then harder examples. Okay, so I'm going to wait a second just to see if anyone has anything they want to put in the chat that they're worried or they don't get or they don't understand. Not very many steps to that. Now, the big difference to note is that the reason why I don't have anything with 0 is because it just says is greater than. So whenever you have a greater than symbol, I don't need to account for 0. But you'll see an example in a second where there's a less than symbol, and we'll have to adjust accordingly. Hey, Michael went to the bathroom without asking. Michael, you know what that means. Gotta write you a detention. You'll get it in the mail. I'll just mail it to you. You'll find it. Jaden, how did I get 81? 3 to the 4th. So Jaden, 3 raised to the 4th power is 81. Darian said, not about this, but when can I ask questions about last night's homework? So Darian, I want you to watch the YouTube video after I'm done streaming. I'll post it to YouTube. Watch that video at the beginning of class. I went over homework. Damon said this seems much easier, but could we see that too? Right? Yeah, that's usually the case, right? It starts off a little bit. I'm glad it's easy for now, though. Okay, so guided practice 3A. Let's take a look at this one. Very, very similar. Okay, the only difference is, and the reason why I'm showing you this problem is because it's telling you that if there's an equal sign, it's not going to change anything. So you'll notice the one difference is it's greater than or equal to. That doesn't change the problem. So we would still have x is greater than or equal to 4 cubed, which would mean x is greater than or equal to 64. Okay, very basic. Nothing changes in that problem. Just instead of just greater than, it's now greater than or equal to. Okay, 3B, guided practice 3B, changes the game up a little bit. Nothing major, just a little bit. You'll notice the big difference here is I have a less than symbol. Okay, so my less than symbol changes one major aspect, and that's this. When I actually solve, or I actually rewrite this logarithm in exponential, I would have x is less than 2 to the 4th. All I'm going to do is add this part of the inequality. So I'm just going to add 0 is less than x, which is less than 2 to the 4th. Again, reason being is because I don't want my answer to be negative a million, because I know that's not on my domain. So there's no point of including that as my solution if it's an extraneous solution. Right? So we got to be very careful with remembering the domain of our logarithms. So that's the only difference, is 0 is less than x, which is less than 2 to the 4th. Meaning 0 is less than x, which is less than 16. Ends up being my final answer. Okay, so take a second before I move on. Give me some feedback in the chat if you guys are good and you're ready to go, move on. If you're confused still. And if you're good, you can move to the next page, so 480. Haven't said all good, all right. Nick, thumbs up, perfect. All right, cool. Cool. So guys, just remember for your homework, part of your homework will be similar to that. The biggest thing that's going to probably cause issues is this problem. So just remember that you got to include that 0. Jaden says, will the problem change how you set up the problem up if there was a number where the x is? Yeah, so if that's the case, Jaden, basically that's going to be an equation. So you're not going to see a problem where it's going to be like log base 2 of 4 is less than 4, if that makes sense. So you're not going to see type of problem because that's just a basic calculator problem. So I don't think no one's really concerned on whether or not you can throw that in your calculator. So good question, but you probably don't have to worry about that. All right, so moving on to page 480. I'm just going to read the top of this page here. So I'll switch back to my facing screen cam here. All right, so it says the following property can be used to solve logarithmic inequalities that have logarithms with the same base on each side. Again, whenever we solve those, last night's homework, okay, when we solved logarithmic functions, we only solved them, or we only could solve them, was because they had the same base. Exact same situation with inequalities. So whenever you have an inequality, they have to have the same log base on either side of the inequality. And then that's kind of your hint, like, okay, we can go through and we can do this process. It mentions to exclude from your solution set values that would result in taking the logarithm of a number less than or equal to 0 in the original inequality. Again, that's something we've talked about based off of last night's homework. So same idea, we're going to have these inequalities, right? If you get an answer that says x is less than 3, there's a lot of those solutions that aren't true. Because for a logarithm, x can't be less than 0 or equal to 0. So if you just say your answer is less than 3, well, that's including -1. That's including 0. That's including negative a trillion, right? And none of those are solutions to the original logarithm or logarithmic inequality. So we just want to be careful. We only want to include real solutions. That's the key. Okay, so let's take a look at example 4. So actually, sorry, real quick, I forgot about this. The key concept where it says property of inequality for logarithmic functions here. They kind of walk through how they would want you to solve this problem. So very, very basic example here. They say if b is greater than 1, then log base b of x is greater than log base b of y, if and only if x is greater than y. And log base b of x is less than log base b of y, if and only if x is less than y. All right? So same idea as the problems we did yesterday, except instead of an equal sign, guess what? We use an inequality. Their basic example is if log base 6 of x is greater than log base 6 of 35, then x is greater than 35. All right, and this property holds true for less than or equal to and greater than or equal to, which would make sense. Okay, so we are going to do example 4. Let me make sure get my hover cam back on. All right, and this says log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. So log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. That's the problem we're given. Notice right off the jump, we have a greater than sign, which actually works kind of well for us. Might help us out a little bit. So we have the same log base. Those are the same. The only way this statement is true is if x plus 3 is greater than 2x plus 1. All right, which means that solving this inequality, I subtract 1 and I get 2. I subtract x and I get x. So 2 is greater than x. Or, I'll just write or x is less than 2. So those are the same answer. Now I'm actually not going to even circle that because I don't want to confuse anyone. That's not my final answer. Okay, the question says to solve the inequality, which we did, but it doesn't want us to include any extraneous solutions. So, how do we find that? Okay, well, they talk about this in the next little paragraph, but what I'll show you here on the paper. So the idea is this. Okay, we know an extraneous solution occurs when inside this parentheses, you get a value of 0 or less. Or inside this parentheses, you get a value of 0 or less. Because we know inside that parentheses, you can't have 0 or a negative number. Again, because of the domain of our graphs. So we want to look at then, when is x plus 3 less than or equal to 0? When is 2x plus 1 less than or equal to 0? That's the question we're asking. When are those true? Okay, now those are basic algebra problems. So I have x is less than or equal to -3. I have 2x is less than or equal to 1, which means x is less than or equal to 1/2. Oh, I apologize. That should be -1. And that should be -1/2. My bad. Okay, so those are two situations where those inside those parentheses might turn into 0 or less. Okay, so what we're looking for then, and it says this in the book, it says exclude all values of x for which x plus 3 is less than or equal to 0, or 2x plus 1 is less than or equal to 0. So what you get is that when x, in this case, is less than or equal to negative 3, or when x is less than or equal to negative 1/2. All right, so this becomes my point. So this negative 1/2. Now I want to see if you guys can follow along here on why I only really care about that negative 1/2. Because x is less than or equal to negative 1/2 includes everything less than or equal to negative 3. Hopefully that makes sense. Again, x is less than or equal to negative 1/2 includes everything up here as well. Because things less than negative 1/2 would be like negative 1, negative 2, negative 3, negative 4, negative 5, and so on, right? Things less than negative 3 would be negative 3, negative 4, negative 5. So you can see how like this set is included in this one. So really what I'm worried about is that value of negative 1/2. All right, and this is telling us that negative 1/2 is going to be like, kind of you think of like my lowest value. Let me make this a little bit up. Hopefully you can see. Let me just double check my camera to make sure you can see. Yeah, okay. So negative 1/2 has to be my lowest possible value. All right, can't get any lower than that. And then x is in between that value, negative 1/2, and also it's less than 2, which you guys could see right back at the beginning or earlier in the problem. So everything I have highlighted in blue gives you your answer. So we know just from the beginning x has to be less than 2. To get the actual solution set, we then have to figure out, okay, what's my lowest bound? Or what can x not be less than? Which ends up being negative 1/2. Okay, so there's a couple new things in that problem. I understand it's not going to be like immediately click necessarily. So I just want you guys to take a second, process that, absorb it. Let me know any questions you have. Okay. Will we be going over homework and office hours, Molly? Yeah, I'll be here from 1 to 2. So I'll be live from 1 to 2, so you guys can hop in any questions you have. Yeah, we'll go over. I have to help out other students, obviously, but if there's no one else in here, whatever you need. Damon, yep, spoke too soon. Okay, Damon, I understand. There's a lot more to this problem. Just try to take it step by step. I think the very first part of the problem, everything above this red line, at least right now, I'm really hoping that we can get that under control. So if we can really understand that everything above the red line, I'm pretty happy. Below that, it gets a little bit confusing. I understand. Do we need to write negative 1/2 is less than x, which is less than 2? Yes, Maddie, you do. So this is how you want to express your final answer here. Definitely want to express our final answer there. Chris said he's lost. Okay, understood. We're going to do another practice problem. Tanis, what page? Okay. Maddie, 480. Oh, you answered his question. All right. Jared said he's good. All right. So, I understand a little bit of difficulty. I'm going to flip this page. Hopefully you guys had that all written down. And then we're going to try another one. Same idea, same process. Okay. So the question is to solve. This is going to be guided practice. So log base 5 of 2x plus 1 is less than or equal to log base 5 of x plus 4. Okay, so this is the problem you're given. Now, I want you guys to do the first part. Okay, meaning I want you to find at least the first inequality, the solution to the first inequality. So if you guys remember the last problem, we got to the point x is less than 2. I want you to just get to that point with this problem. So I'm going to give you like a minute or two. Find that first, and if we can get through there, you got half the problem done. And then we can work on the second half as a group. So just give me your answers actually. So put your answers in the chat once you get that initial answer. Nick, x is less than or equal to 3. Good. Damon, close, except instead of equals 3, you want to keep the inequality. So you have x is less than or equal to 3. Yeah, so make sure, I understand you guys are just typing in the chat real quick so I get it. But yeah, it looks like we're getting 3, which is really good. All right, so good. So you guys got again, that's like half the problem. Okay, you can get half the problem done. So let me talk about that. Let's look at that. So if you're still wondering where are people getting this 3 from, the bases are the same on either side of my inequality, which means that 2x plus 1 has to be less than or equal to x plus 4 in order for that statement to be true. In order for this left side to be less than or equal to this right side, the inside of the parentheses have to also be less than or equal to. All right, and then this is just algebra. So I get x is less than or equal to 3. So I subtract an x from both sides to get x. I subtract a 1 from both sides to get 3. All right, I'm just going to box this in with a blue marker just so you guys know, like, hey, all right, making progress. We got part of my answer. Whoops, I kind of made that worse. My bad. I was supposed to make that better. It should be less than or equal to. All right, now what I want to show you real quick, just so we're on the same page with this. If you look at Desmos, all right? So we got an answer as x is less than or equal to 3. All right, now my concern is this. There are extraneous solutions, and we know about those. So we know that there's going to be values that are going to make log base 4 of x plus, or sorry, log base 5 of 2x plus 1. We know there's going to be values that we can put in there that is going to make that negative or 0, and that's no good because those don't exist. So let's look at an example. What about like negative 2? All right, if I were to plug in negative 2 here, I would get log base 5. So let me put that into Desmos. Log base 5 of 2 times negative 2 plus 1. Okay, and notice it says it's undefined, right? So we have an undefined. That's not good for us. Make sure you just get rid of that. Okay, that's not good for us. If we get an answer that's undefined, that means it's not a solution on our set. So maybe if anyone's wondering, why did Mr. Harris choose negative 2? Well, the answer we got was x is less than or equal to 3. So a value that's less than or equal to 3 is negative 2, right? So that's me just trying values less than or equal to negative 3. So this shows that, okay, not every solution is going to work. Because of that, that's why we do this second step to this problem. So because of that issue, that's why we have to do this next step. And that next step here is going to be to say, okay, when is 2x plus 1 less than or equal to 0? And when is x plus 4 less than or equal to 0? Because those are the two values. Those will give us the two values that are going to make this statement not true, that are going to give us values that are undefined. Okay, now from here I'm pretty confident you guys are able to solve these inequalities. Pretty confident in that. So I get 2x is less than or equal to negative 1. So x is less than or equal to negative 1/2. And x is less than or equal to 4. Again, I'm very, very confident we can do that part. So if you remember to do these inequalities, to set those up, then I'm pretty sure we can work from there. It should be a negative 4. Didn't really write that very neat. Okay, now this brings me back to my point earlier, right? I have two different inequalities, one where x is less than or equal to negative 1/2, one where x is less than or equal to negative 4. Well, negative 4 is less than or equal to negative 1/2. Okay, so I can just ignore this. I'm just going to cross it out. I can ignore it. All right, it's not a concern to me because my x is less than or equal to negative 1/2 already accounts for that. It already takes care of that because negative 4 is less than negative 1/2. All right, so that tells me that those are my solutions. Okay, this is telling me that I cannot have a value of x that's less than or equal to negative 1/2, which means negative 1/2 turns into my lower bound, or it turns into the farthest most left point I can go, or my smallest value. All right, so that means that has to be less than x. X has to be greater than negative 1/2, or it becomes undefined. And also from earlier, that blue box I marked earlier, we also know that this has to be less than or equal to 3. So we basically take those two blue boxes and we combine them. So those two blue boxes kind of turn into my solution. Again, that first part, just by judging the chat, just kind of looking at what I was getting, the feedback I was getting, I think you guys are good with that. So you can at least get those. The second part is just saying, okay, where does my graph become undefined? And that's only true when inside the logarithm is negative or 0, which is why we set up 2x plus 1 has to be less than or equal to 0. All right, I know that's a lot of new stuff, a lot of talking I've done, but see if you guys can think about this. So Nick, if you combine them, then why does the negative 1 have less than x not have an equal to? Okay, so Nick, very good question. So Nick is asking, how come I go from here, where x is less than or equal to negative 1/2, to this is greater than? Okay, now this is why. Because this inequality I set up here, so that inequality I set up there was to give me solutions I don't want. So these are the solutions I do not want. I don't want any value of x that's equal to negative 1/2 or less than. So the solutions I do want are going to be the opposite of whatever that is. So if this is telling me x is less than or equal to negative 1/2, I only want solutions where x is greater than negative 1/2. Because again, in the red circle there, those are values that make this problem bad. It makes it undefined. It's no good. So we don't want those. So we do the opposite. Yeah, so Chris, I just saw your question. I think I addressed that a second ago. So see if that explanation makes sense. Again, the red circle we don't want. That inequality was just telling us, okay, this is the solutions that can't exist. So we have to, our solution set should be the opposite of that. And in the chat real quick, guys, give me some feedback. How do I check my work? How do I know I'm right? What can I do? Got it. Okay, good. So yeah, what do I do, guys? What do I do when I want to check my work? Because we know with inequalities, we can always check our work to see if we're right. Plug in a number. Yeah, specifically, Nick, we want to plug in a number for x. Okay, then let me ask again to the chat in general, what do I expect to get? When I plug a value of x in, what should I expect to get out? So for example, if I wanted to choose a number x that's in this range to see if I'm right. Yeah, exactly. Okay, good. Tanis, Nick, perfect. A number within the set, a number that's not undefined. Perfect. So like I pick a number between -1/2 and 3. Let's say 0. Okay, let me go back to my camera so you can see my screen. Let's say I chose 0. So I would have log base 5 of 2 times x, but our x is going to be 0 plus 1. Notice I get a value. Okay, so that kind of puts together Tanis's and Sierra's and Nick's answers, right? If you look, I see that I have an x value of 0 that's in my solution set, and it gives me a value. It actually produces a number. It's not undefined, which is good. That's good news for me. And then I can check a number outside of my interval, so something that's not in there, like 4. Let's try 4. So if I go back to Desmos. If I go back to Desmos and I plug in instead of x equals 0, x equals 4, I should expect to see what? And now I'm not going to wait for you guys to chat because it's on a delay, but I'm sure in your head you're thinking, oh, I should expect it to see it's undefined, and what happened? So notice what happened. I don't get a number that's undefined. So are we wrong? Now I'll actually wait, even though there's a delay, I'll actually wait. Why did I get a value and it wasn't undefined? And I'm going to hide what I'm doing here because I'm going to kind of give away the answer, but you guys think about that. That was kind of weird. It shouldn't have been undefined. Sierra says more than one answer. Okay, that's a good idea. Definitely a good prediction. Tana said it's in the set. Okay, so I think I know what you're saying, but I don't necessarily agree. Because if not, like 4, the value 4 is not in that set. It's outside of that set. But if it doesn't give us an undefined answer, what's another opportunity we might have where this would make this untrue? I guess I don't know if I worded that great, but I'll give it one more minute to see if anyone has any ideas. If it doesn't give us undefined, but it's still not a solution, why might that be? Okay, so I think I'll dive in to why, and I'll show you using Desmos here. So if you guys look, this first equation, this was the left side of the equation. I plugged in 4 for x, and I got my value of 1.36521, right? Now this is the right side of the inequality, and I got a value of 1.292. Those aren't equal to each other, right? And the original inequality said that the right side should be greater than or equal to. Well, is 1.292 greater than or equal to 1.365? No, it's less than. So just because for inequality, just because you might not get an answer that's undefined, you might get an answer that just doesn't make the statement true. That makes the statement false. So your solution set, going back to my work here, your solution set's going to contain solutions that make either the statement true or defined. Okay, that's how you find your solution set. All right, so I know that was a lot, kind of in that last little step, but hopefully that was okay. Jaden said, "Are you going to check the homework for tonight when or if we come back to school?" Yes, Jaden. Any homework that isn't turned into Google Classroom, I'll be checking when you get back. If you get back. Cross your fingers. Okay, so guys, a reminder, today, 1 to 2, I'll be here. I'll do a live stream. From 2 to 3, I will be answering emails. So unless someone's still needs help, I'll go a little past 2 if I need to. But if no one's here, I'll end the stream for my office hour. I will be available from 2 to 3 by email. And honestly, after 3, if I'm not doing anything, it just depends on what's going on. But I might answer emails. I'm pretty good about that. So just let me know if you guys have questions. Again, this homework assignment for tonight, you can find in Google Calendar, which is in my Google Classroom. It's not an assignment you're turning into Google Classroom, so you don't have to worry about that. But it is an assignment, like Jaden said, where I do plan on checking it when and if and when we get back from school or get back to school. So make sure you guys get that done. I'll be going over the homework, so any questions you have tomorrow we will be addressing. If you want to work on it in the next hour or during my office hour, hop in. Any questions you have, I will be more than happy to answer. If there's nothing else from you guys are good to go. That was today's lesson. If you're watching on YouTube, hopefully it was beneficial. Email me if you have any questions if you watched on YouTube. Thank you for those who participated today. I really do appreciate you guys staying involved, staying engaged, and just keep it up. I think this is really useful. You guys are all going on to your next math class, whether that be stats, pre-calc, whatever. This stuff's going to help you, keep you fresh, and also when we get back to school, right, I don't want you to fall behind. So keep that in mind. Okay, Darren said, "I love the lasagna in the back." Yeah. Jaden, yes, thank you. You're welcome, Sierra. Thank you. Luke, you're welcome. Hope you guys have a great day. Stay healthy. Be smart. Have a nice day, Damon. Thank you. Yeah, just make sure you guys stay safe. Stay safe out there. Take care of your families. Thank you, Mr. Harris. Have a good day. I will, Molly. Thank you. All right, I'm going to be signing off, guys. Take care.